writing purposes, it's just so much faster. So when we write equations, we're going to always use point slope. And I would just say leave it in point slope. Leave your final answer in point slope unless they specify otherwise, in which case it's a quick hop, skip, and a jump to get it to slope intercept. So the reason point slope is more efficient is you just need any point along with the slope, and then you can write it. Whereas this one, you also need the slope, but you can't just take any old point and plug it in. You specifically have to know the y-intercept. So it's always easiest because this one's not specific about which exact point it uses. So in this particular one, regardless of which way you go, you have to calculate your slope. So 6 minus negative 2, that's our y2 minus y1, over negative 3 minus 3, that's our x2 minus x1. 6 plus 2 is 8, over negative 3 minus 3 is negative 6, and that reduces to negative 4/3. So now with that slope, and either of the points that they gave me, I'll just use this one because why not? You just write your equation. Y minus and y1 is going to be your y coordinate of your point, 6, equals negative 4/3 x minus your x coordinate of the point we decided to. So x minus negative 3 is going to turn to plus, x plus 3. Okay? Now if you decided to use the other point, you'd use this one. Y minus negative 2 is going to be y plus 2 equals negative 4/3 x minus 3 if we decided to use that one. Now either of those answers is correct. They're the same line. The equations obviously look totally different, but they're the same line. When you are then asked for slope-intercept form, now you just have to distribute and get the y all by itself in either or. They'll both end up looking exactly the same once we get them into that format. So if I take this first one and I make it y minus 6 and distribute, negative 4/3 times 3 is how many thirds? Negative 12/3, which is negative 4. Negative 4/3 times 3 is negative 12/3. Negative 12/3 is the same as negative 4. Add your 6 over, and you get negative 4/3 x plus 2. But if it doesn't specify, just write this and be done with it. Okay? Any questions? All right. Quick sketching of graphs. I know you know how to graph things, y equals mx plus b form, so I just picked a couple special cases. What does the graph for part A look like? Maria. Okay, be more descriptive about where it is. At 3. So a straight line, all lines are straight. Did you mean horizontal? Horizontal line at 3, so 1, 2, 3. Not crossing the x-axis, perfect. Now, B probably looks a little funny to you, I would think, because normally you would be used to instructions for something like that to say solve, right? But it's not solve, it's to sketch it. So in the context, sketch the graph of this. In the context of it, you have to realize this is a graph of something, okay? You have to solve for x, so you subtract 12 from both sides, divide by 3, and they want you, this isn't a solution, this is a graph that they want you to graph. This is a, what kind of line? Let's go with Michelle. Vertical line at negative 4. 1, 2, 3, 4. Very good. It's a little abnormal to see it in that 3x plus 12 equals 0 format, but Thank you. But that's what they're getting at when they say graph and it looks like that on the homework. Don't be thrown off, okay? I haven't really gotten to the bottom of this next, well, not the question, but I don't know if it's on tonight's homework or if it's elsewhere in the book. But at moments, they write the equation of the line like this. This isn't point-slope format. This isn't slope-intercept format. There's a third format called standard format, which you're probably somewhat used to. Something like this. Does that look familiar? Write this as standard format. An example of this would be like 3x plus 2y equals 12. You're kind of used to seeing equations of lines written in this format as well. Although we don't usually write equations in that format. But nonetheless, that's a third format we're familiar with. For whatever reason, this textbook, and I'll ask Mr. Hill and see if he has any insight as to why they do this, if it's a calc thing or not. But they'll write equations of the line and they'll have it all equal to 0 for some reason. So if you look in the back of the book and that's the format that it's in, just quickly rearrange yours and get it all equal to 0 and it should be a match. Does that make sense? Okay. Again, if it's multiple choice and all the 4 answers are in that format where it equals 0, well, just get everything equal to 0 and cater to that format. But I'll see if I can get back to you about why that format is even used and how it's helpful. I'm sure there's a reason. I just don't know what it is. Anyway, determining intercepts and then graphing a line according to intercepts, which is a really efficient way of graphing a line because all you need is 2 points and you connect the 2 points on a line and voila, you have the entire line. So how do you find the x-intercept? What do you set equal to what in order to find an x-intercept? The y equal to 0. That's because any x-intercept is on the x-axis and has a y-coordinate of 0. So I'll just put that note there and then we'll do it. 6x minus 3 times 0 plus 15. Your 3 times 0 is going to cancel. Subtract your 15 over and divide by 6. And reduce negative 15, 6, both divisible by 3, negative 5 halves. Which to plot as your x-intercept is like negative 2.5, so right around here. And to find our y-intercept, that's going to be a point on the y-axis. Any point on the y-axis has an x-coordinate of 0, so you plug in an x-coordinate of 0. And our y-intercept is now 5. 1, 2, 3, 4, 5. And then just connect with a straight edge. Definitely the most efficient way to graph something like this. Okay? If something is in slope-intercept format, we usually graph a little bit differently, but if you were going to say across the boards what's generally the most efficient, graphing by intercepts is probably it. Okay? Because it works no matter what format the line is in. That's the benefit. All right. Flipping over to the back. Find the slope of a line passing through these points. A little bit tricky here because our x-coordinate is a binomial, comma c, and our y-coordinate over here is a binomial, but we're just going to find the slope following our slope formula. So our y2, which is a plus c, minus y1. So if you want, for organization purposes, parentheses might help your eye see this, how it's supposed to be perceived. So y2 minus y1 over the second x-coordinate, x2, minus x1. So the parentheses help obviously for visual organization of this, but they're critical right down here. Yes? Because if you don't have them and you don't distribute your subtraction to the binomial that you're subtracting, you're going to get the wrong answer. So in our numerator, a plus c minus c is just a. And in our denominator, we have a minus the a, which cancels, and then minus negative b, which is just b. Where? I did. I didn't show it. I did a minus a, and that cancels, and then minus a negative b becomes positive b. Okay. Any questions there? All right, and you're going to see some of these where you're just finding the missing value. Who's got some direction as to how I'm going to set this up? How about, I'll take a volunteer. How am I going to find y? Do we all see y? This is a 4, and this is a negative 4. Those are not y's. There's our y. Go ahead, Liam. Perfect. So he knows the slope, but he's missing a piece of a point. So he just says the slope equals, so the slope is 1/3, equals y2 minus y1 over x2 minus x1. Perfect. And then this is just 6, because the double negative 4 plus 2. And then you solve something like this by what method? Everybody all at once? What'd you say, Nathan? Cross multiplying. So this is 1 times 6. And then when we multiply this by 3, we're going to have to distribute. It's going to be negative 12 minus 3y. And then solve. Add 12 to both sides. Divide by negative 3. Voila. Uh-oh. What are we going to do now?